Hi all, in this video I would like to talk about some hints for week 4 assignment. Of course, you may just skip to the parts that you are confused about, or you can just check the answers here. Oh no, not checking the answers, just checking the approaches. Okay, so I will only talk about some questions that most students asked me before. Right, I think for number 1, 2, you do not have much problem. Looking at number 3, I would like to talk about the presentation to make sure that you are following this. You must start from the line required ratio and then equal to the length ratio, and then put bracket power 3 to make the dimensions agree. And then finally, you have to write in this form, something colon something, because this is the ratio. Don't write in fraction form for the final answer. So you may also do part B yourself. Okay, and then we move on to number 4. For number 4, you should note that actually x and y itself does not have any units. It means that for your final answer, you write x equals to something. You should not write any unit here. Otherwise, it's wrong. So for this type of question, it's very easy. You only need to write the length ratio, area ratio, and then match the dimensions, and then that's fine. Okay, so you calculate yourself. Okay, so for number 5, it's also about a similar solid type questions, and here you should look at the information given. You have the height. Okay, so when you look at the word height, it means that this is a dimension 1 measurement. It means that this is the length ratio. Okay, and then we have the curved surface area of cone A, so it means that this is a dimension 2 measurement. Okay, so about part A, what should we write to present it well? You must write let x cm square to be the curved surface area of cone B, otherwise you have no symbol to start with. And then you do it like this, okay, length ratio, area ratio, and then match the dimensions. Okay, so you can see that actually for every question you do it like that. So it is actually quite simple, but you have to write the presentation well. Okay, so for part B, you can see that there is another cone C, and then you have to judge whether it is a similar cone to cone B or not. Okay, so I would think part B is very hard to present only. Okay, but the idea is not really that hard because you only need to check whether the length ratio square is the area ratio. If so, then it may be. You still cannot say it must be, it may be, but if it is not, then it must not be. Okay, so you can see the idea here in my drafts now. Okay, so you can see that for the length ratio square, if it is equal to the area ratio, don't fall into the trap. It's not always that they are similar. You can only say they may be similar. So you cannot draw any conclusion unless you know all the length, all the area, all the volume, which is actually quite impossible from the information given. Okay, so however, if you can see that length ratio square is different from the area ratio, then you can draw the conclusion. They are not similar. Okay, so if you see the questions like this, I think you can draw the conclusion 100% surely that they are not similar. Otherwise, I cannot ask you. Okay, so look at part B. It is quite hard to present. How do you write the things? You have to write everything using words precisely. It means that you have to write a lot of words here. You have to write height of B to height of C, and then you calculate something, and then you calculate curved surface area of B, curved surface area of C, you calculate another ratio. So please don't mind writing so many words. You have to because you have no other ways. And then you have to check whether this ratio, when you square it up, you calculate it, and then you see whether it is the same as this ratio. If they are not the same, then you can draw the conclusion that no, they are not similar. Okay, so for this part B, it is very hard to present, so try to follow my way when you do your assignment. Okay, now look at number 6. I first tell you the idea, and then next we'll look at how to present. Okay, first, you can see that the surface area is not given to you. You only know that the football is 64% of that of a basketball. So you don't have any value, so we have to let 8 cm square, for example, and then you can write the surface area of football to be 0.648. Then you can write down the radius of the football to be 12 cm, and then for basketball, I don't know, so maybe I let x cm here. Okay, so you can see that in this question there are two unknowns, because for surface area I don't know, so I have to let a or let y or let m, let p, you have to let. And then for the radius of the basketball I also have to let, so you have to write two symbols here. Okay, so after you're letting everything, then you can write out the equation. And then for the next line, you can already eliminate the A. Okay, so you can continue yourself and finish this question. Okay, number 7 is a more challenging question and more students have asked me before, so I would like to discuss it with you in details. Okay, so looking at this question, you can see that the given information is the area ratio. Okay, but note that this is not the pyramid to frustum, but it is the pyramid to a big pyramid. Okay, so we have to see very clearly which two parts of this question are similar. So you have to draw like what I did here, and this is a small pyramid to the bigger pyramid. And you have to note that this 776 is not the big pyramid, but it is just the volume of the frustum. So it means that if you have a certain part here, you have to add this to become the big pyramid area. Okay, because for part A, you are asked to find the volume of the larger pyramid, so I can actually let x cm cubed to be the volume of the larger pyramid directly. Okay, so after you let it, you have to express the volume of the small pyramid and volume of the larger pyramid here like this. So you have area ratio is 9 to 64. So the volume of this small pyramid will be x minus 776 and then x. Okay, so how can you match the dimension between area and volume? You can write like what I do here. On the left hand side, you have the area ratio. So you take the square root to be the length ratio, and then power 3 to be the volume ratio. Okay, so finally you try to solve it out and you can do it yourself. Okay, so for part B, I do not do it for you and I only highlight some keywords for you. Okay, so it is given that the area of the upper base of the frustum is 90 cm square. So here I want to emphasize that actually the upper base of the frustum is the base of the smaller pyramid. Okay, so the corresponding parts to the larger pyramid would be the very big base areas here. Okay, so if I know that this is 90 cm square, then you use the ratio 9 to 64, then you can find that this is 640 cm square. Okay, so you have the answer x from part A. I suppose you can find out the height of the larger pyramid, and then you can also find out the height of the smaller pyramid, and then you have the big minus small to get the height of the frustum. So you can try yourself. I don't give you the answer here. Okay, so now let's look at number 8. I think this is relatively easier than number 7, but it's also quite similar to the idea that you have to add the frustum to the smaller cone. Okay, so look at part A, xcm to be the height of F first, and then you have to see which two parts are similar. It's not the frustum that it is similar, but it is the bigger cone to the smaller cone. Okay, so the volume ratio is not 27 to 485. Instead, it should be 27 to 485 plus 27. You can just claim it to be the ratio of the volume of the smaller cone to the bigger cone. And then for the height ratio, you will have 7.5 cm to 7.5 plus x. Okay, so you can do it yourself. Okay, and then for part B, I think the answer is not hard to find, but how to present, you have to write the words precisely. You have to write curved surface area of S to curved surface area of L, and then you can calculate it first. Okay, after you calculate it, then you can just write required ratio would be something to something minus something with a bracket here. Okay, why? Because you are actually subtracting the smaller cone away from the bigger cone in order to obtain the frustum's curved surface area. Okay, finally, if you would like to try question number 9, which is a really challenging question here, if you really want to try, you can look at some hints here, but I'm not going to give you the working. Okay, first, when you try to find the volume of the water inside, of course, is half of the original volume. So how to find the volume of the original part? You have to know that the volume for a cylinder is pi r square h, and then you take half of it. And then for volume of the cone, it would be 1 over 3 pi r square h. Alright, so you can calculate yourself and then take 1 over 2 of it. This is not really challenging. Okay, and then look at part B. You're going to find the wet surface area. It means the area in contact with water. Also, which part is it? First of all, you have half of the base circle and then half of this curved surface area. Okay, so how to find the curved surface area? This is learned in grade 8. And then this is 2 pi r to be the base circumference multiplied by the height, and then you take half of it. Okay, so half circle is easy, you do it yourself. And then for this part, it would be half of the curved surface area. Okay, so you try to calculate yourself for part B. Okay, now look at part C. I think this is the most challenging part of this question. There may be different ways, but I suggest you to use similar solids, and then first you try to find out the volume in this small part first. Okay, so how much water is more than that circular cylinder, and then what is that part inside the cone? Okay, so how to get that? First of all, you have found the volume of water in part A. So use this value to minus 2 pi RH, which is the volume of the cylinder, then you can get this volume, or maybe I call it YCM cube here. Okay, so how do you use similar solid? When you let x to be the height of the smaller cone of the upper part, then you can say x over 12 equals to the volume ratio. Okay, so what is the volume ratio? It is 1 over 3 pi r squared 12 minus y over that thing. Okay, so this is the volume ratio, and then you match it with the dimension. And finally, you can find x. Okay, so what is the water level? It is not x, it is the total height minus x. Okay, so you can try yourself, but it's really challenging. Okay, finally, look at part D. Find the wet surface area of the container in figure B. So first of all, you have to know that it consists of 3 parts. The first part is the base because it's in contact with water, and the second part would be the curved surface area of this cylinder. And these 2 parts are quite easy to find. The base is just pi r squared. The curved surface area of the cylinder is just 2 pi rh. They are easy. But the last part would be the curved surface area of this very small frustum here. Okay, so for this part, you can calculate it by the bigger cone's curved surface area, smaller cone's curved surface area. Okay, so how to do it? You judge yourself and try to enjoy the remaining parts of this assignment. I expect to collect it before Sunday 23:59. Okay, see you. Bye.